Hi guys, welcome to African Tech Gurus. We are going to go through the quiz for preprocessors, and the very first question that they have is this portion of code using the library stdlib? So if you ask me, it is not using it. In fact, it is just including it. So hash include is a preprocessing directive that helps us to include or take whatever blocks of code is in this library and just put it in our source code for us to be able to move to the next step. So it is not actually using the library, it is just including it as part of the source file for it to be able to create an intermediate file for it to move to the next step of compilation. The next question that we have is the preprocessor generates assembly code. This is not correct. It does not generate assembly code. The step that generates assembly code is the assembler or the assembling stage. So it is false. What are the processes or the steps of compilation? This one you should have it on your fingertips because it's very, very simple. The very first step is the preprocessor step, which you looked at in the previous video and which is what we should look at mainly in this video. The next step is the compilation step or stage, where the file which was previously produced in the pre-processing stage is actually moved into the compilation stage, and we actually get a file from this. I can actually pull that up and we look at it. So here we do have what they're asking. We have the preprocessor, which will include, not use, it will include all the header files, all the macros, and whatever else is needed for the source file to be able to move through the GCC step for us to eventually get an executable file. And after the preprocessor step, we're going to do compilation, which helps us generate assembly code. And once you have assembly code, we move to the assembler stage or assembling stage, where we generate machine code that now we can link either statically, well, using static library or a dynamic library, and we get an executable file which will contain the machine code for us to actually execute the program. So those are the steps. Make sure you have them on your fingertips. The other question is the preprocessor generates object code. This is not correct because, as we have seen, object code is generated after the assembler stage or the assembling stage. So that is also not correct. The next question that they have is, what will be the last 5 lines of the output of this code that they have given us once we run the GCC E command, the GCC E command. So the gcc.e command followed by the name of the source file or the code file that you have, what will it do? It will just indicate to the compiler or the compilation process to stop at the preprocessing step. And what might be the use of this? We might want to actually see what is the content of the header files that we have included. We might want to see how the macros have been expanded and much more. So that is basically what this command will do. And what will happen is, at this point, is it will provide this, which will contain the code with all the header files, all the macros expanded for you to be able to use. So here, when you're using null, it will be replaced with this actually, because this is what it contains. Just saying that if there is no information in that location, just let it be null. So this will be your answer. So what will be the output of this program on a standard 64-bit Linux system? So basically what will happen here is we'll use the header files, we'll include them, and we will define a macro which is called int to basically contain character. So remember, a character can only be the size of 1 byte. So here, if you use int I, remember you had already said that anywhere where there's int, let us replace it with character. So basically, each and every step where int is becomes character. So this is basically character I, and here we are saying, or we are initializing I, which is a character, to 5. So a character always has a size of 1 byte. So basically here the answer will be 1. Yes, it's that simple, no need to complicate it. So here the preprocessor removes all comments. This is true because the preprocessor does remove the comments for it to be able to move to the next step, for it to compile, and it just makes the work of the compiler easier because it adds what is needed. So the libraries, the functions, the macros, whatever body of code they contain is actually included, and whatever is not needed is actually removed. And comments are some of the items that are not needed, so they will be removed. The other question is, why should we include guards in our header files? So they are very important because they help us avoid the problem of double inclusion when you're dealing with the include directive. You wouldn't want to double include your header files more than once because now it creates a problem in your file. So that is why we would really want to use guards in our header. The next question is, this is the correct way to define macros. The macro sub. So the macro that they're referring to is this, the one that I am highlighting. So here we are defining a macro called sub, and we are giving it the specific arguments or commands that we want it to. So they're just asking us if this is the right way or not. This is not the right way. The right way is this way. This should be the right way, where you have the name of the sub, the arguments it should take, and whatever you want the macro to contain or to do. So this is the right answer. The other question is, what is the GCC option that runs only the preprocessor? We've mentioned this before. It is the .e, and it tells the compiler to stop at the preprocessor step. Null is a macro. This is true. We have looked at it in the previous one, that it will just tell all anywhere where there is null, it will be replaced with the void statement. So the other question is, what does the macro table size expand to? This is it. You can go through it. The first thing we're doing is we're defining buff size to be 1020, and then we're also defining table size, which is a macro that makes reference to another macro, which is buff size, which we have initialized previously, and we have stated what it should contain. The next thing we do is we undefine buff size. It contained 1024, so it should not contain 1024. And the next thing we do is we define it to 37. So at the end of the day, when we expand table size, it will expand into buff size, which now contains 37. So 37 is our answer. The other question is, the macro underscore file underscore expands to the name of the current file input in the C string constant. This is true. If you need more explanation on this, just let us know. We can cover it. The other thing, or the other question is, the preprocessor links our code with libraries. This is false. What it does is it includes it. The linking stage is the last step before we actually get our executable file. So this is done at the linking step, not at the preprocessor step. The other and final question is, this code will try to allocate 1024 bytes into the heap. This is very true because we are defining a buffer size to contain the value 1024, and we are creating a memory allocation that has 1024 bytes, which is practically the heap. So this is a true statement. Hope this has been helpful. If you like the video, please don't forget to give it a thumbs up. It promotes and helps us do more of this. If you're new to this channel, thank you so much for watching. Thank you for reaching this step, and we'd like you to subscribe. And if you're a returning subscriber, thank you so much. We appreciate you each and every single day. Until next time, happy coding.